Hello everyone, I would like to present our paper ID-Blau, Image Deblurring by Implicit Diffusion-based reBLurring Augmentation. The camera shakes or object movements cause unpleasant motion blurs. Such blurs are usually non-uniform, leading to locally and globally undesirable artifacts. Therefore, Image Deblurring aims to remove these blurry patterns from a single blurry image. Although previous methods have improved deblurring performance through architectural designs, we note that an effective data augmentation strategy for image deblurring has been largely neglected. Therefore, we aspire to develop a groundbreaking blur augmentation method to generate diverse blurred images to help deblurring model. Our contribution, ID-Blau, introduces a stable and controllable blur augmentation strategy to enhance dynamic scene image deblurring. First, we model a continuous blur condition field to implicitly represent blur orientations and magnitudes as blur condition maps. Then, ID-Blau can take a sharp image and a blur condition map to synthesize a blurred image even if it was not seen in the training set. For example, condition Azizka blur condition map computed from the GoPro training set. We can create conditions B and C based on condition A to synthesize new reblurred images. Condition B is condition A with rotated orientations, and condition C is condition A with added camera motion blur. We can generate diverse training pairs using our method to enhance the performance of deblurring models. Experimental results show that ID-Blau significantly improves existing deblurring models and performs favorably against state-of-the-art deblurring methods. Next, it is our reblurring process. We parameterize the blur patterns of an image with their orientations and magnitudes as pixel-wise blur condition maps to simulate motion trajectories, implicitly representing them in a continuous space. The diffusion model has proven effective in covering the sample distribution to generate high-quality images. Therefore, ID-Blau is based on a conditional diffusion model that uses a blur condition map C, a sharp image S, and a noise map to generate a blurred image B. By altering the blur condition map C, we can simulate various blur scenarios and augment diverse blurred images to complement existing datasets. For example, the blur condition map in the blue frame is orange, indicating a blur direction to the bottom left, which results in images with bottom left blur. The blur condition map in the red frame is purple, indicating a blur direction upwards, which results in images with upward blur. Training deblurring models on these varied blur scenarios improves their deblurring capabilities. Here are some visualization results. By creating different blur condition maps, we can generate various blurred images. For instance, the original blurred image is shown in the second column. In comparison, the third column displays an image with a horizontal blur orientation, while the next column shows a vertical blur orientation. The last two columns illustrate changes in both the orientation and magnitude of the blur. Additionally, this demonstrates that through pixel-wise blur condition maps, we can produce a diverse range of blurred images to enhance the capabilities of our deblurring model. Moving on to the experimental results. We adopted 4 recent image deblurring methods: MemoNet, Restormer, Stripformer, and the state-of-the-art FT Former. To demonstrate the effectiveness of ID-Blau, each deblurring model was pre-trained on 10,000 generated training pairs for 500 epochs, followed by fine-tuning on the GoPro training set using default settings. As seen using our ID-Blau powered version, all 4 models show an average performance increase of over 0.45 dB across different datasets. Experimental results show that ID-Blau significantly improves the performance of 4 deblurring models across 4 widely used datasets, demonstrating ID-Blau's effectiveness as a data augmentation strategy for deblurring. These are real-world dataset deblurring visual results. The results show that ID-Blau enhances deblurring visual quality compared to baselines, restoring images that baseline methods cannot deblur and performing well even in unseen dark scenes, restoring details more effectively. These are demo videos. On the left, we have the results with only the magnitude of the condition adjusted. As we can see, the images become increasingly blurry with each adjustment. Next, we show the outcome with only the orientation of the condition adjusted. The images are gradually rotated from 0 to 359 orientation, Lastly, we present the results when both the magnitude and orientation of the condition are adjusted. By modifying these conditions, we can achieve any desired blur style for the image. In addition, we conducted ablation experiments. This figure shows two blurred images from GoPro and their reblurred versions by ID-Blau. Since GoPro's blurred images are generated by blur accumulation, they contain unnaturally overlapping artifacts. In contrast, ID-Blau can generate similar blurred images by simulating continuous motion trajectories, yielding more realistic blurred images without such discontinuous overlapping artifacts. Therefore, ID-Blau can generate more realistic blurred images to improve the Deblurring model's performances. We explored the effect of the number of augmented samples. The left plot shows that using more than 10,000 blurred images yields diminishing returns in performance improvement. Hence, we selected 10,000 images as our dataset size for the most effective performance enhancement. As shown in the right plot, ID-Blau consistently outperformed with the same training complexities, considering both pre-training and fine-tuning processes. In the following experiment, we compare the performance gain with a diffusion process. We observe that even without using the diffusion model to generate blurred images, our Deblurring performance still significantly exceeds the baseline. This demonstrates the specified blur condition design. When we incorporate the diffusion model, it achieves an additional performance gain of 0.23. Finally, this is our contribution and our code is publicly available. For more details, you can scan this QR code. Thank you for listening.